we're going to combine the limit concepts that we have developed in sections 2.1, 2.2, and 2.3 to solve the two important problems illustrated in figure 1. The solutions of each of these problems involves a common concept called the derivative. The derivative has many important applications both from the elementary calculus to multivariate calculus and far beyond. So we haven't come to the sections of optimizations, but when we come to optimizations, the derivative can tell us where the best place to sit in a room if the room is filling up with smoke, and at what time it is best to sit there. And the reasons why we learn math, not because we love derivatives, but we know that we learn math because it gives us tools like this derivative to solve important problems. So let's take for example, if on one fine day, you travel to KBP and then you go home at 3 p.m. and you pass the marker of 120 kilometers, and at 3:15 you pass let's say the marker of 140 kilometers. So from these two informations you can tell that you have traveled for 20 kilometers on 1/4 hour, or you can say that you have the average velocity, which is 80 kilometers per hour. This is also called as the average rate of change, or we can define it in this way. For y equal to f of x, the average rate of change from x equal with a to x equal with a plus h is defined as this: f of a plus h minus f of a divided by h. Now we can apply this concept for a situations that not related to the velocity, which is the, for example, revenue analysis. I'll put this one over here. Okay, so the revenue analysis, the revenue in dollars from the sale of X plastic planter boxes is given by R of X equal to 20X minus 0.02 X squared. What is the change in revenue if production is changed from 600 planters to 800 planters? So the X stands for the how many planters we have. We can then put it as this: A R of 600, then that will be 20 times with 600 minus with 0.02 times with 600 square. So that will be equal to 4,800. R of 800, then we'll just substitute the x with 800, and then we'll get 20 times with 800 minus 0.02 times with 800 square. Then we'll get 3,200. So when we try to count this, what is the change on the revenue from 600 to 800? Then it will be R of 800 minus with R of 600, and that will be equal to 4,800 minus 3,200, 1,600. Yeah. So B is this one. What is the average rate of change in revenue for this change in productions? So it will be R of 800 subtract with R of 600 divide by 800 minus with 600, and then we'll get this one already, 1,600 divided by 200, and then we'll get the answer is 800. So this is the average rate of change in revenue. So again, the average rate of change is the difference on the numerator and on the denominator, and we can call this as a difference quotient. So let's put it on the velocity example. This is the case of velocity. A small steel ball dropped from a tower will fall a distance of y feet in x seconds in this formula: f of x equals 16x squared. Now figure 3, which is this one, it shows the positions of the ball at 0, 1, 2 and 3 seconds. At 0 you have position start, which is 0 seconds, so the distance is 0. On x equals 1 second you have 16 feet, on 2 seconds you have 64 feet, and on 3 seconds you have 144 feet. Now for the falling steel ball in example 2, which is this, find the average velocity from x equal 1 second to x equal 2 seconds. So that will be f of, for A, I'll put it over here, f of 2 minus f of 1 divided by 2 minus 1. So f of 2 will be 64, and then minus with f of 1, that will be 16, over 2 minus 1, in this case is 1, so we'll get 48. B is the average velocity in simplified form from x equal 1 second to x equal 1 plus h second. So I'm going to put it over here. Okay, so it will be f of 1 plus h, right, because this is the given information, minus with f of 1 divided by 1 plus h minus with 1. That is the average rate of change. Now f of 1 plus h, let's put it into this formula. So it will be 16 times with 1 plus h square minus with f of 1, which is 16, divided by 1 plus h minus 1, then we'll get that's equal to h. Yeah, expand 1 plus h square, then we'll get 16, and then times with 1 plus with 2h plus with h square minus with 16 divided by h. So then we'll get 16 plus with 32h plus with 16h square minus with 16 divided by h. Then 16 and negative 16 cancel each other. We'll have the common terms, which is h times with 32 plus with 16h divided by h. So simplify this, we'll get 32 plus with 16h. This is the average velocity when you have from x equal 1 second to x equal 1 plus h. And when you put the h, let's say it's 1, so you'll get x equal 2 seconds, you'll get 32 plus with 16, which is 48. Now c is the instantaneous velocity. The instantaneous velocity is defined in this way. Limit of h approaching 0 for f of 1 plus h minus f of 1 divided by h. So we have got this f of 1 plus h minus f of 1 over h, that is equal to 32 plus 16h. So we can just substitute limit of h approaching 0 for 32 plus with 16h, and then we'll just substitute the h with 0, then we'll get 32 as the answer. This is the instantaneous velocity at x equal 1 second. So by the definitions, the instantaneous rate of change can be defined as the limit of h approaching 0 for f of a plus h minus f of a divided by h. The adjective instantaneous sometimes eliminated or omitted with the understanding that it refers to the instantaneous rate of change. So it's not referring to the average rate of change. So I'll present it again. The average rate of change will be just this, without limit. But when you have instantaneous rate of change, you'll have the limit over here. Yeah, that's the difference between the instantaneous rate of change and the average rate of change. Now we want to consider a geometric interpretations of it. In geometry, a line that intersects a circle in 2 points like this one, P and Q, is called a second line, while a line that intersects a circle in exactly 1 point like this, only at P, is called a tangent line. If the point Q in this figure is moved closer and closer and closer to point P, then the angle between second line and the tangent line gets smaller and smaller up until the second line is equal to the tangent line. Now we will generalize the geometric concept of second line and tangent line of a circle, and we'll use it to study the graph of functions. So let's put it this way. We have the graph of y equal to f of x, and then let's say there's a line through 2 points over here, which is called a second line also. If a comma f of a and a plus h comma f of a plus h are 2 points on this graph, then we can use the slope formula from the sections 1.3 to find the slope. So that will be delta y over delta x. Delta y is defined as a f of a plus h minus f of a divided by the a plus h minus a, which is equal to h. So we can use it to solve this kind of problem. Given f of x equal to x squared, find the slope of the second line for a equal to 2 and h equal to 2 and 1 respectively. So referring to this one, let's say the first case is when a equal to 2, and then you have a 2 plus 2, right? The h is 2, and then the other one is h is equal to 1. So I'm going to write it 2 and then 2 plus with 1 over here. So for a, put it over here, that will be f of 2 plus with 2 minus with f of 2 divided by, in this case, divided by 2, since the h is equal to 2. And then the other one will be f of 2 plus 1 minus f of 1 divided by 1 over here. Oops, I'm sorry, it's supposed to be f of 2, not f of 1. And then since we have the f of x equal to x squared, then we can just put it here. So f of 4, that will be 4 squared minus with 2 squared over 2. Again, this is the f of x. So 2 plus 2 is 4, x squared. So that will be 4 squared minus 2 squared divided by 2. And then we'll get 16 minus with 4, which is 12, divided by 2, and then we'll get 6 as the answer. For the second, you'll have 3 squared minus with 2 squared divided by 1. So 9 minus with 4 and divided by 1, you'll get 5. So that's how to get the answer. B, find and simplify the slope of second line for a equal to 2 and h any non-zero number. So it means that you have f of 2 plus with h minus with the f of 2 divided by h. So we'll have a 2 plus h squared minus with, in this case, 2 squared divided by h. So then we'll have expand 2 plus h squared, that will be 4 plus 4h plus with h squared minus with 4 divided by h. 4 and negative 4 cancel each other, and then we'll have the common term, which is h. I'll put it in parentheses, 4 plus with h divided by h. Cross this 2, we'll get 4 plus h. This is for B. C, find the limit expressions in part B. So it means that we put it of limit of h approaching 0 for f of 2 plus h minus f of 2 divided by h. In this case, we already have it simplified to 4 plus h. So then we'll put it, the h is equal to 0. Then the answer will be equal to 4. Yeah. D. So D answer will be same with C. Yeah. Find the slope of graph and slope of the tangent line at a equal to 2. It means that from this second line, when the h becomes 0, you'll get that, yeah, this is referring to limit of h approaching 0, so that's also equal to 4. So that's how we obtain it. Okay, now let's try to define what is the slope of a graph and tangent line. So the slope is given like this. Limit of h approaching 0 for f of a plus h minus f of a divided by h. Then if we can define it this way, we are now ready to introduce some terms that refer to that limit. Yeah, so to follow the customary practice, we use x in place of a, yeah, and think of the difference quotients. So it will be this one. This is how we define the derivative of f at x. In summary, we can interpret the derivative as this one is called f prime as the slope of tangent line. That's the first. We can put it as the instantaneous rate of change, and then also as a velocity. So the 4-step process for finding the derivative of a function's f will be find f of x plus h, find f of x plus h minus with f of x, and then the third step is divided by h, and the fourth step is to put the limit for step 3. So let's try to do it for 8x minus 2x squared. We'll have f prime of x is equal to 8x minus 2x squared. If I have f prime of x, f of x, then let's define f of x plus h. Then it will be 8 times with the x plus h minus 2x plus h squared. And then we'll get 8x plus with 8h minus 2, and then expand this will be x square plus with 2x, and then plus with h square. Then we'll have 8x plus 8h minus 2x square plus with 4xh plus with minus with 2h square. Okay, now let's put the fourth step, okay, the step 4. Okay, so let's just come to limit of h approaching 0 for f of x plus h minus f of x divided by h. Then we'll have limit of h approaching 0, and then 8x plus 8h minus 2x squared plus with 4xh minus 2h squared. This is the f of x plus h. Subtract with this 8x minus 2x squared, 8x minus 2x squared, divide by h. Okay, so I'm going to take this out from the parentheses, so it will be negative 8x plus 2x squared, and take off the parentheses over here is also. Then let's see what we can eliminate. The 8x with negative 8x, and then 2x squared with negative 2x squared. So it left us with the limit of h approaching 0, and then we have h as the common terms times with 8, and then plus with 4x minus with 2h divided by h. So in limit we can just simplify it, and then we'll get limit of h approaching 0 for 8 plus 4x minus 2h. So the answer will be 8 plus with 4x, and this is the f prime of x, which is the derivative of f at x.